Write the correct order. Write the correct order for rate of reactions. Number one, this is for SN1. No, one, this is how many? This is for SN2. This is for SN1. Next, C6H5 whole size carbon, and here you have, let us suppose, chlorine. C6H5 whole twice, CH and 1 chlorine. C6H5, C2 and then chlorine. What else you can do? So this one is for SN1. अरे सवाल समझ में आ रहा है नहीं आ रहा है? कहा कहा सवाल समझ में आ रहा है आपको?
Yes, sir.
चलिए 5 सवाल कीजिए. बेसिकली ए बी सी हम बोल दे रहे हैं. ए, दिस इज बी एंड दिस इज सी. ठीक है. शुड आई डू वन फॉर यू? कैसे करना है आपको समझ में आ जाए.
Yes, sir.
Okay. So SN2, in this, first of all, you will see what is different. So all the alkyl group are same and the halogen atoms are different, right? So when the alkyl
Ye-
groups are same and the halogen atoms are different, we will see how does the rate of SN2. It depends on the halogen atom. So it depends on the size. As the size is large, the SN reactions are faster. So the size of A is largest, then B, and then C. Since it is directly proportional, so as the size increases, the reactivity will also increase. So size is increasing in this manner, right? इधर से इधर size increase कर रहा है, so A will be the fastest, followed by B, then C. ठीक है, तो ऐसे करना है. Got it? Mr. No, got it?
Yes, sir.
नहीं. Okay. Response to done, Taha. Assalamualaikum. Am I audible?
हेलो अस्सलाम वालेकुम सर।
वालेकुम सलाम। क्या हुआ, बहुत लेट है आज आप?
जी सर, एक्चुअली मैं ट्राई कर रही थी ये ज्वाइन करने का, पर हो नहीं रहा था, उसमें एड्रेस इनवैलिड आ रहा था।
अच्छा।
हम्म।
Taha, please send the answers, whatever you have done. ताहा, हुआ आपसे या नहीं हुआ, ये पहले बताइए। यस ताहा। आवाज आ रही है आपको ताहा? हेलो, एम आई ऑडिबल ताहा? कहा audible आवाज आ रही है आपको? हेलो?
जी सर।
नो, आई एम आस्किंग कहा. मरी मधुन, in this class rate of SN1 and SN2.
क्या सर?
Rate of SN1 लास्ट क्लास आपने अटेंड किया था
हाँ
ऑफ
सर।
हैलोरीन, ऑफ
सर
हैलो
आपकी
एल्केन
आवाज
हैलोरीन.
सही से नहीं आ रही।
आई एम आस्किंग, डिड यू अटेंड द लास्ट क्लास ऑफ हैलो एल्केन हैलोरीन?
नो सर, नॉट ऑफ दैट वन।
डिड यू वॉच द रिकॉर्डिंग?
नो
फिर कब कीजिएगा ये सब काम? है तो इसमें हम क्या ही बोले.
सर।
So in the first case, the race of SN2 it is going to depend on the size of group. Here also in the second case, since the alkyl group is same, we have to see the size of leaving group. Here the leaving group iodine is bigger than bromine, and then chlorine is the smallest. Here the rate will be A, then B, and C will be slowest. In the next case, we have SN1. In the SN1, first of all, if you have benzene rings, then you have to see the largest number of benzene rings. So A has largest number of benzene rings, then B, and then C. So A will be fastest, followed by B, and then followed by C. In the fourth case, here we have different alkyl group and the same leaving group. So we look at the alkyl group and they're asking the rate of SN1. So this first alkyl group is going to give you 3 degree carbocation, going to give you 2 degree, and is going to give you 1 degree carbocation. So as the degree of carbocation increases, the stability also increases. So A will be fastest, followed by B, and then followed by C. In the last case, we have different alkyl groups and same leaving groups. So we look at the alkyl group, and in the alkyl group, this is 3 degree, this is 2 degree, and this is 1 degree. The rate and two, it depends on the it is inversely proportional to the size of bulky groups on alpha carbon. So 3 degree has largest number of groups, that is why it will be very slow. So the rate will be A is slowest, then followed by B, and then followed by C. ठीक है ना? So copy कर लीजिए, पढ़ा तो है नहीं. ठीक है ना? जब
ओके
रिवाइज
सर।
कीजिएगा, then you will understand this. कहा I
जी
am not
सर, मैं
audible, I
आज
guess.
देख लूंगी रिकॉर्डिंग्स।
Okay.
Yes, sir.
नहीं, what happened? I was calling you for a very long time. आपने एक भी
No, sir,
आंसर
I
नहीं
couldn't
भेजा.
hear you, sir. I was joining back.
चलो.
Hello?
Yeah. I heard you. I heard you. आपने आंसर क्यों नहीं भेजा लेकिन?
Oh, yes, sir, I was doing that.
रेज योर हैंड वंस यू डन. कितना टाइम लग रहा है भाई? रेज योर हैंड गाइस इफ यू आर डन. चलो. Right, next SN reactions of haloalkene. Nucleic substitution reactions of haloalkene. See, just give me a few minutes. मतलब एक दो दिन और will be over. 1 2 3 4 बंदा बन गया. देखिए ध्यान दीजिए जरा. Now थोड़ा सा ना बस आप लोग यहाँ पे थोड़ा दिमाग लगाइएगा. Right? What will happen if I replace with aqueous KOH or NaOH? What is the negative part in KOH and NaOH? Guys.
H minus.
What? Sorry, Taha.
NaOH. Sir, what were you asking?
I am asking what is the negative part in NaOH or KOH?
Sir, H minus. OH minus.
OH minus, right?
Yes.
So OH minus is going to replace the halide. है ना? R और X में क्या negative होगा? Obviously the halide X will be negative ना? So OH negative is going to replace X. We'll get ROH, that is alcohol. Similarly, if you have water, then also you are going to get alcohol, ROH. Now, if you have, let us suppose R dash C triple bond C negative Na positive. ठीक है, यहाँ पे आपको समझ में आ रहा है that this negative part is going to replace. So R will be replaced by X will be replaced by C triple bond C some other R dash. Then if you have ammonia NH3, then ammonia has lone pair and this lone pair attacks and you will get RNH2. If you have R dash COAT, then COO it is in O negative, and you will get R dash COO. This Ag will be replaced by R. Okay, this R from the haloalkane. Next, if you have lithium aluminum hydride, then as the name suggests, we have H negative and X will be replaced by hydrogen, so it will become alkane. Next, we have two very important, KCN and AgCN. Now, in both the cases, it seems like we are going to get R and X will be replaced by Cn. But in the case of Cn, it gets replaced by Cn. In the case of AgCN, it gets replaced by Nc. Now, what are the names? This is alcohol. This is alcohol. This is alkyne. This is amine. This is ester. This is alkane. This is cyanide. This is isocyanide. Copy this down, then raise your hand. लिख लिया आपने था ठीक Now we are going to look
Yes,
at the case of we are going to look at the case of KCN AgCN. उससे पहले please write a question. Write the products for following. बस aqueous KOH. तो देखिए कैसे प्रोडक्ट बनाना है. Everything will be as it is. Br will be replaced by OH, as you can see यहाँ पे ना. X is replaced by OH in aqueous KOH. So everything as it is, and the Br will be replaced by OH. ठीक है. If you want to write the reagent, like what will be the byproduct, it will be K. Chlorine plus KCN. ठीक है. Chlorine is going to be get replaced by CN. चलिए बाकी आप कीजिएगा जरा. Give you questions. चलिए प्लीज कीजिए. Do these three. Taha, am I audible? Taha, hello.
Yes, sir.
What happened? Send me
Yeah.
answers.
Sir, okay, sir.
आप देखो यार, फोटो क्या भेजा है आपने?
Yes, sir. वहाँ से वापस
ताहा,
भेजता हूँ.
ये स्क्रीनशॉट में भेज रहे हैं आप? क्या हो रहा है हमारे, मतलब आपका कनेक्शन ठीक नहीं है क्या?
सर डिस्कनेक्ट हो गई थी, उसके बाद से ज्वाइन ही नहीं हो रहा था।
क्या प्रॉब्लम है भाई? आप ही को होती है लेकिन ये प्रॉब्लम।
सर पता नहीं, नेटवर्क का इशू है शायद यहाँ पर।
आप कहाँ हैं अभी?
मैं हूँ तो घर में ही, रियाद में ही हूँ।
अच्छा। ठीक है ताहा, दोज आर करेक्ट। OH, आई थिंक सेकंड वाले में आपने थोड़ी लापरवाही कर दी, नहीं ठीक है। NC, and here you will have this propane, na? This we don't show hydrogen like this, as a hydrogen दिखाया नहीं जाता, right? We'll directly get what? Alkane. Here we have 3 carbon atoms. यहाँ पे क्या होगा? क्लोरीन निकल जाएगा और हाइड्रोजन लग जाएगा। मेक सेंस? कहा?
Okay, sir.
ओके, ठीक है। अब यहाँ पे जो आपके पास इंपॉर्टेंट पॉइंट है, रिएक्शन आप यहाँ से लिख लीजिए। मरियम बतूल, ऐसे भी आपको तो एक बार देखना ही पड़ेगा लेक्चर, बिकॉज स्पीच बीच में मिस हो रहा है आपका। रिएक्शन ऑफ एल्केन विद KCN gives cyanide, nitrile, both of these words are used, but with AgC gives isocyanide या isonitrile. ठीक है, they will ask you to explain. So when the reaction happens with, we're going to look at 2 cases. पहला, when it happens with KCN and when it happens with AgCN. ठीक है, ध्यान सुनिएगा जरा। तो मेन इंपॉर्टेंट पॉइंट जो यहाँ पे ना आपको याद रखना है इज दैट KCN is ionic, KCN is ionic, but AgCN is covalent. KCN, if since it is ionic, it is going to exist as KCN exists as K positive and CN negative, where carbon triple bond nitrogen. Both of these have lone pair electron and there is a negative charge overall, है ना? अब यहाँ पे this both carbon atoms and nitrogen atom is able to donate the electron, but AgCN, since it is having a highly covalent character, Ag is going to have a bond carbon, and this carbon will be triply bonded with nitrogen atom, and this nitrogen atom is the only one which is able to donate the electron. ठीक है, तो AgCN is covalent, and you will write AgCN exists as it exists as like this. Now C in Cn negative, carbon attacks on haloalkane, acting as nucleophile as carbon-carbon bond is stronger. Carbon-carbon bond is stronger. है ना, both carbon nitrogen, both of them can attack. You can attack कौन करेगा? Carbon. Then predominantly what will attack? The carbon will attack because it is going to have a strong bond as with other carbon atoms. CC bond क्या होगा? Strong होगा. Right? That is why we get what? RCN. The alkyl group, it is connected with the C atom. And this is alkyl alkyl cyanide. In this case, the nitrogen atom attacks. In AgCN, nitrogen attacks on Rx as it is the only nucleophilic atom. Only electron rich atom बोल देते हैं, वही nucleophilic वही मतलब होता है. Only electron rich atom. ठीक है. Therefore, what will happen? You will form R, and this alkyl group, it is attacked by nitrogen atom, so NC. That is alkyl isocyanide. Copy this down. Raise your hand once you're done. Please raise your hand once. A similar reaction happens with KNO2 and AgNO2. इसको भी थोड़ा लिख लीजिएगा. Reaction of haloalkane with KNO2 gives RONO, but with AgNO2 gives RNO2. ठीक है. So here also the same reason is present. KNO2 is ionic and exists as K plus and NO2 negative. Now, what is the structure of NO2 negative? It is going to be like this: nitrogen double bond O, bond oxygen. This oxygen will have negative charge, and यहाँ पे lone पे nitrogen पे भी है, and here is going to have with oxygen also, right? Now, since oxygen atom has negative charge, और दूसरे देखिए बहुत सारे factors हैं यहाँ पे. This is not the factor. Oxygen atom में negative charge है. That is one factor because why it attacks. Other factor is that both of these oxygen atoms are able to attack because there exists a resonance between them. ये नेगेटिव यहाँ जाएगा और फिर ये यहाँ पे नेगेटिव हो जाएगा, राइट। तो यहाँ पे देखिए ध्यान से, तो इन दिस केस बोथ दी ऑक्सीजन एटम कैन अटैक, देयर इज अ रेजोनेंस बिटवीन देम। अच्छा, द नाइट्रोजन लोन पेयर, एक तो नाइट्रोजन बीच में है, इट इज डिफिकल्ट फॉर नाइट्रोजन टू अटैक, जो टर्मिनल में है दैट कैन अटैक क्वाइट इजीली बिकॉज साइड साइड में ज्यादा आसानी से अटैक हो सकता है, देयर इज नो स्टेरिक। बट एक जो मेन फैक्टर क्या है यहाँ पे, सिंस ऑक्सीजन हैज नेगेटिव चार्ज, it attacks the haloalkane and forms, or since oxygen is attacking, ONO bond banega, that is alkyl nitrite. AgNO2 is covalent and exists as AgONO. ठीक है, now both the oxygen atom and the nitrogen atom, they are having lone pairs, both the oxygen and nitrogen ना, because यहाँ पे अब नेगेटिव चार्ज कहीं पे नहीं है, ऑक्सीजन कैन ऑल्सो अटैक एंड नाइट्रोजन कैन ऑल्सो अटैक। अब यहाँ पे कौन अटैक करेगा, तो हियर व्हाट हैपेंस, सिंस nitrogen is less electronegative, nitrogen atom is less electronegative, it can easily attack Rx and form RNO2, that is known as nitroalkane. Now you can lower your script, let me know once you're done. चार रिएक्शन के आंसर आप फिर से दीजिएगा। Br का one is with KCN, the other one is with AgCN. KNO2, AgNO2. Send the answer on my WhatsApp. हाँ होगा नहीं होगा? हो गया था।
sir, I'm doing it on.
जल्दी कीजिए।
Yes.
हाँ थोड़ा जल्दी कीजिए।
Sir, I send it to in the in WhatsApp.
व्हाट्सएप भेज दिया आपने?
Yes, sir.
तो बताइए, मेरे पे मुझे नहीं आया, सॉरी। ये देख रहे हैं। अरे यार, क्या किया है आपने? एवरीथिंग एज इट इज एंड br will be replaced by cn. एवरीथिंग एज इट इज br will be replaced by nc. ऐसे ना करना होगा।
Oh,
Everything
yes.
as it is and the chlorine will be replaced by ONO. Everything as it is and chlorine will be replaced by NO2. लीजिए इसको जरा। इसके हो जाएगा ताहा। इस ताहा एम आई ऑडिबल?
Yes, sir, I send it to you on also.
चलेगा। जस्ट गिव मी अ सेकंड। NO2 CNS, वेरी गुड, थैंक यू। हो गया पढ़ने में, पता नहीं क्या जवाब दिया है आपने। ठीक। लास्ट एक चीज इसके बारे में लिख लीजिए, एम्बिडेंटेट न्यूक्लियोसाइड्स। राइट द टॉपिक। एम्बिडेंटेट न्यूक्लियोसाइड, ठीक है। राइट हियर, न्यूक्लियोसाइड that has more than one donor atoms but can attack by only one of, ठीक है। For example, we have carbon triple bond carbon, and both of these are nitrogen and carbon. Both of them have lone pair electrons. Carbon has a negative charge. Now, the attack can happen through carbon, and it can happen through nitrogen as well. But it happens only through, but it happens only through what? Only through one of the atoms. है ना? Either carbon or nitrogen किसी से भी हो सकता है, लेकिन एक ही से होगा. So tendency to attack is present in more than one atom, right? So we have more than one donor atom. So that is why it is what? Ambidentate nucleophile. दोनों तरफ से अटैक हो सकता है। जैसे जो एम्बीवर्ट होते हैं, दे आर इंट्रोवर्ट एट सम कंडीशंस एंड दे आर एक्सट्रोवर्ट एट सम कंडीशंस। दोनों एक जगह नहीं हो सकते हैं। एग्जांपल, सिमिलरली यू हैव amphibians. Amphibians, they live at in water and they can live in earth also. दोनों में simultaneously they cannot be in water and the earth, right? So the same thing, there will be two donor atoms, but both will not attack. Only one of them will attack. Make sense? इस वाला भी कहा?
Yes, sir.
ठीक है। From here, or it can attack from one of these oxygen atoms. Both of these oxygen atoms are, like, there are three donor atoms यहाँ पे. Fine. Although if you are going to make bond with oxygen atom, it is going to be the same thing whether it is the first oxygen or the third or the second oxygen. But we have three donor atoms. So we can attack the एक से ही होगा. Please write this down. Let me know once you're done.
Yes, sir, I'm done.
Just give me a second.